Alright, here we are at chapter 33. This is electric fields. This is a pretty short chapter. And on Friday when we meet in class, we're going to talk more. We'll probably have a math quiz on either Friday or Monday. I'm leaning towards probably having the quiz on Friday so I can get it back to you on Monday. Or if you want to come by and get it, because I think we're going to test on Tuesday next week over this unit. So we'll meet in class on Friday. Remember, we're off on Wednesday and Thursday still. So here are our notes on 33. Oops, why did I do that? Alright, just as the space around Earth and every other mass is filled with a gravitational field, the space around every electric charge is filled with an electric field. So everything that has mass has a gravitational field, and last time I checked, everything had mass. So there's gravitational fields everywhere. But there aren't electrical fields everywhere. You actually have to have a charge to have an electrical field. So if you have a positive charge, like a cation, or a negative charge, like an anion, you'll have an electric field associated with that. Just as a gravitational force holds a satellite around the Earth, electrical forces hold an electron in orbit around the nucleus. So basically what I'm trying to show you here is they both work the same way. Gravitational fields and electrical fields both work as fields around an object holding things in place. An electric field has magnitude and direction, so it is also considered a vector. When drawing an electric field, the arrows always point towards the negative charge. Your arrows always point towards the negative charge. Where lines are further apart shows the field is weaker. So the further away, and I'm going to draw you pictures of this on Ask Me To on Friday. I'll show you pictures. Electric potential energy per charge is the total electric potential energy divided by the amount of charge. This is called electric potential, or we also call it potential difference. I call it potential difference probably more than anything else. The unit for this, for potential difference, is the volt. Voltage, that's a joule per coulomb, so your energy or work per charge. They're normally called voltage. On page 525, I want you to read about that. One of the things I'll make sure I cover here is the capacitor. This is where you store electrical charges. Electrical charges or electrical energy can be stored in here. Remember the movie Back to the Future? They had the flux capacitor. It held 1.21 gigawatts. So capacitor is where you can store charges. Basically, as the charges come through and the energy comes through, you can store them to use for later. Just about every electronic device out there has a capacitor that does this. They're found in almost electric circuits. There are pictures on page 526 in your book. Like I said, these are very short, but we're going to talk more on Friday about the rest of this.